intermediate code generator. So this is the example. So for this, what we will make? Syntax tree. How we can make? X is equal to. So first we will write x equal to. Now what we have? A plus a. So we start from bottom. We'll write a plus. So a plus a. Now next is what? Plus a. So we will make another plus and a plus a plus a, another plus a. So in the similar way we'll write plus a, one more plus a. So we'll write plus a, and which is equal to. So we'll make like this. So we can say a plus a plus a plus a plus a, x is equal to. So this is the syntax tree for this. Now what we will make? DAG, which don't do repetition. And here we can see that many repetitions are there. So how we will make it? We'll see here. X is equal to will remain same. X equal to will remain same. Now we need to see how we solve this without repetition. A plus a plus a plus a. So first we will write a and plus. Now a plus a in both direction. So we'll write like this. A plus a. Instead of this, we'll write a plus a in both direction. A plus a. Now what is next? Next is plus a. Next is a plus a is complete plus a. So how we will write? We'll see here. We'll write plus a plus a plus. This is for plus. This is a plus. So a plus a plus a. Now another plus a is there. So again we'll write in the similar way. Plus a. One more a plus a is there. So again we will write in the similar way. Plus a. So this is a plus a plus a plus a plus a, and we need to connect this with equal to. So this is the DAG representation of a plus a plus a plus a plus a, a plus a plus a plus a plus a, x is equal to. So now come to the next, that is postfix notation. Postfix notation. Postfix notation. So how we will write? For a plus a, for a plus a, what we will write? A plus. What we will write? A plus. Then next plus a, next plus a, we will write a plus. So we will write a plus a plus a plus a plus, then again plus a plus, then again plus a plus, and at the end what will come? Equal to sign. So we'll write here equal to sign, and here what we'll write? We'll write x, right? X. So this is the postfix notation. A plus a, for a plus a plus, then again plus a plus, again plus a plus, again plus a plus, equal to sign, and x will start right from the beginning. Now come to the 3 address code. How we can write 3 address code. So for a plus a, we will take one variable t1 is equal to a plus a, Again, for one more plus a, we will take another variable t2, which we will write t1 plus a. For another a, we will take another variable t3. Here we will write t2 plus a. For another a, we will write another variable, that is t4 is equal to t3 plus a, because total 5 a's are there. We can see here total how many a's? 2, 3, 4, 5. So for 2 a's, we will take t1. Another third a, we will write t1 plus a. Another fourth one, we will write t2 plus a. Another fifth one, we will write t3 plus a. Now the next is, we need to assign all this to x. So we will write x is equal to what? Last one, that is t4. So this is all representation of intermediate code generated in the form of syntax tree, form of tag, in the form of postfix notation, and in the form of 3 address code.